Hi guys, welcome back to another video. This time I think we'll look at improving the spawning system a little bit. So if you remember from the previous video where we did the initial spawning system, the game master will always try to spawn an enemy some distance away from the player, like you can see, and it's always spawned in the same direction. So if we just keep shooting like this, we can essentially immediately kill the new unit as it comes into the world. And this doesn't make for terribly exciting gameplay. Instead, we will want to have a system that can intelligently find places in the world and spawn enemies around the player. I haven't exactly decided yet how I want the spawning rules to be, but I was thinking that perhaps we could write a system that given the player's position, can try to find places along the edges of the player's view, or perhaps slightly outside the edges of the player's view, and find good places that that can be used for spawning. And I was thinking we could try to use the nav mesh for this system. Actually, if we move like this, I think those guys are gonna spawn inside that block. Yep, there they are. Yeah, so this is one of the problems. Like if you stand somewhere in a place that's not really doesn't take the spawning into account, now that those guys might appear inside walls. Now, for example, there's going to be one inside that wall as well, and so on. But yeah, so let's try to use the nav mesh for spawning. And if we look at what we have here, we have this is what the nav mesh looks like. Let's get rid of this menu. So like we previously went over, these white parts are considered traversable, and these parts that aren't covered by the white mesh are considered to be impassable. So essentially we could spawn enemies anywhere on this mesh, but there are a few wrinkles along the way. Like, first of all, we don't want to spawn an enemy on top of this block here. That is not supposed to be actually part of the nav mesh. Now, I should probably improve the actual nav mesh generation a little bit, so that I would strip out these parts. I haven't really thought about how to do that yet, but I was thinking we could just handle that case currently in the game by essentially creating a new object that we place somewhere on the traversable nav mesh. And when we select a point somewhere on the nav mesh, if we can get from, let's say, imagine here that the player is our reference point. If we select a place somewhere and we make a query so that we can actually reach the player from that point, then that would be a valid place to spawn an enemy. In this case, if we were to select a point up here and we try to generate a path from here to here, it wouldn't succeed, because we have this drop here, which is not covered by the nav mesh. I think that'll probably be like the most flexible way of handling this thing now. So essentially, we'll be doing a little bit of brute forcing, in the sense that we'll not accept certain points and get new ones until we find one that actually matches our requirements. But that should be fine. Another problem that we have is that how do we actually prevent enemies from spawning inside of other objects that don't block the nav mesh, such as these characters, for example. Like if we were to select a point right beneath this clump of enemies, that would not be good because they would appear inside of these guys, and as we've seen in previous videos, that leads to weird behavior. So we somehow need to figure out, is this place actually vacant? Is there anything going on in that place currently? And if there is, then we need to reject that position as well. So quite a lot to do to actually just select valid spawning points, but yeah, this is starting to get pretty fun. So let's get right to it. Okay, so I quickly covered in a previous video that we have in the navmesh runtime part, we can find a random point around the circle on the navmesh, and that should give us a rough point centered around some vector with the max radius. If we actually go and have a look at what it does, this is still part of the game engine, but when we get down to this method here, now we're actually inside the detour navmesh query, and this is the middleware that I'm using to actually generate and query the navmesh. And this has a function called find random point around circle, and in here this is maybe a little hard to see, but there's a comment here that says the location is not exactly constrained by the circle, but limits the visited polygons. So that might give us results that aren't exactly within the circle we're given, but it should select these polygons here on the nav mesh based on where we are. So it should be quite good enough. And then of course if we center the circle around the player, we don't actually want the enemies to spawn inside, or we don't want them to spawn right next to the player. That would be kind of annoying and unfair to the player. We want them to spawn kind of actually outside some inner circle, but inside a larger circle, so that they appear kind of like close to the player but still some distance away. And we don't actually have a method that gives us that. So I think we'll try to brute force that as well, and essentially try to use the bigger circle as our search circle, and then just reject points that are too close to the player. Now, these are kind of hacky ways to solve these issues, but remains to be seen how big of an issue that actually becomes. It's not necessarily a problem. Okay, so that should give us like the rough idea of where the point appears. And then we have the other thing, the problem with the vacancy. So for that, we'll actually want to have a look here in basis scene. So this is the physics scene, and this has a couple of methods here: get sphere overlapping and get convex mesh overlapping. And I think we should be able to use this guy to do a sphere overlap test, and that should be a good enough check, at least for now, to figure out if we can actually spawn something in that place. So we give it a center, a radius. It gives us back currently an actor buffer, so a buffer of how many actors it found there. We don't actually need that yet. We just need the return value of that. So I think I'm just gonna expose this to Zig without this actor buffer, and we can add that later, because we just need to know, like, is there something there or is there not something there. So that should be fine for now, and then when I know how I want to tackle this with Zig later on, I can do that. So let's actually start with doing this. So we go to bind a lot and just copy this guy. And we already happen to be at the physics scene. So we'll need to add the scene CPP pointer, and we'll need to turn these vec3s into interrupt vec3 pointers. Radius is fine. And I think this actor hit types. Let's go to scene physx and overlapping. This is probably a yeah, this is actually just a bit field. So we can essentially just do everything for now, I think, in this Zig version. So we don't need that. We don't need the actor buffer size, and we'll just do center and radius for now. Okay, and now that we have that, we can run our bind a lot generation. Actually, we can get there this way. Hyper Zig source. Oh, sorry. Actually, it's part of the engine, of course. So it's Zig C API and then generate class bindings. And this should have given us our new binding. Yeah, I haven't actually submitted the stuff from last video yet, so I need to do that. But we have the bind physics scene. We'll take that and add it to our engine API. Like so. And then we'll do the function pointers, and they go in the scene module. Like so. And we'll get the new sphere overlapping test here. And we can immediately add this so that we have this whole thing done. So get sphere overlapping is the name of it. We want to have self, obviously, and then we want, I think it was center and radius. Yes, center and radius. So center will be a vec3, and radius will be an f32, and this will return us a u32, so an unsigned integer, unsigned 32-bit integer. And I'm just actually gonna add a to-do here. So to-do add actor list parameters, just so that I know that yes, it's actually missing some parameters here. Okay, and we'll want to do this, and then we will just simply want to call get sphere overlapping self.cpp pointer. We'll pass it the address of the center and radius, and that should be everything we need. That built, so that's fine, and then we'll just add this method to the Zig interrupt. And this is the nice thing about the bind a lot thing. It's like immediately giving me errors about things that I haven't implemented yet. So at least I find this way of binding quite easy. There's a little bit of manual work, and I could get rid of some of the copy pasting, but I have full control over how it binds things, and I get to simplify API in the places where I want to, and I also get to kind of do things like this where I just leave out some parameters for now that I don't need, and then when I know how I want to implement them, I can do that later on. Okay, so we have scene, and we can do the sphere overlapping. So we'll need the actor buffer, physics actor, and let's just do something like physics API, physics actor. So it wants like a list of pointers. So actor buffer, and make it 10 or something. And then we'll do from interrupt. We'll do center and radius. And there's the actor buffer. The actor buffer size is 10, and we'll want to OR together all those types. So essentially all of these guys. It's a little annoying that I don't actually have a type here. Maybe we can add that. Physics actor type all. And that's just going to be all of these guys. Having it here as a separate item has the benefit of, like, if I ever add another type here, I immediately see that, oh, I should put it here as well. Okay, so we'll just have basic places as physics API and physics actor type all, and what did I do? Clearly I broke something. Oh, the joy of C++ programming is to get 1,314 errors because I forgot, I think, a comma. Oh, come on. I already lost that one file. Yeah, it wasn't actually a comma. It was a semicolon. It should have been a comma. Okay, there we go. And of course, with this we can just return the return value immediately. Yeah, I was already complaining about that. So we're building a bit more than we actually need right now. We're building slide, for example, here, which is causing it to take a bit longer. But we're not in a hurry. Okay, let's just let this do its thing in the background. So the next thing we want to do is this thing here. So it's returning the same kind of nav mesh result as find path. So that's nice. We can use that already because we have it in Zig. So let's go to our nav mesh runtime and look at what we have here. So nav mesh ID is supposed to be it's supposed to be return an int32 first of all, and the nav mesh ID here is an int32, and we have the center, which is supposed to be an interrupt vec3. We have a max radius, and we have a writable int32. Oh, sorry, vec3, of course, and need the search box size again. This is a random function pointer that will handle on the C++ side, so we don't need to deal with it here. And that should be everything we need for that. So let's do the has this actually finished? Yes, it did, and nothing failed, so that's good. And now we can go here and we can get the function pointer that we need to add to our nav mesh runtime in Zig. We have it here, and the binding function as well, which is this. Yeah, these are the things that I could probably make bind a lot actually write to the correct place immediately, but I don't exactly know how I want that to work yet, so I haven't done it. Okay, and again with this we can immediately fix up the module so that we have the method available, or the function available rather. Let's go to bind a lot and copy this here. I can actually get the parameters from there. So this is like nav mesh ID, and that's center. Max radius is F32. The result is a vector pointer, and that is also a float 32, and it returns a nav mesh query result like so. And so we have the center here like that. How did we handle that? That's just an enum to int, right? Okay. And then we'll want to have I think it's let's call it like res. I want to have a basis C API interrupt vec3, which is I guess undefined. Is that how I do it? Let's have a quick look in C node, for example. Yeah, that's how you return things to. Yes, that's correct. So that will be the result, the interrupt result. Maybe we'll call it interrupt result. And okay. And yes, so then we can do const result is int to enum nav mesh query result, and then here we'll have the find random point around circle call, and we need to do enum to int nav mesh ID, and then the next parameter is the center, which is the address of C, and then we have max radius, and then we have the address of interrupt result, and finally search box size. And we can do this. And so if we have a result, we'll just assign the value back to that vec3 that we passed in, and that would be vec3 from interrupt result. Finally, we return the result. Oh, and of course now we have like result here and result here. So let's call this something like query result. There we go. I think that should handle it. Not calling that function yet, so it may be that it doesn't give us all the errors yet. That's probably my main gripe with Zig, is that it tends to miss mistakes until you actually call the code that has those mistakes. But hopefully that can be improved in the future, or I'm sure it will and can. Okay, and then we'll need, of course, to implement this on the C++ side. So let's quickly go there and do that. And we'll call that navmesh runtime, and we'll add it here. And again, it's helpfully giving me flack about not having that. Okay, so what did that actually look like? Find a random point around circle. Am I actually using that somewhere? I seem to be. So I have a function here. Yeah, let's do that, but let's not have a specific random engine there for us. Get random float for navmesh queries. Let's add this. This is kind of like, this can then be used for all of the navmesh query random needs. This one is thread safe if you don't pass it a specific random engine. Right. Yeah, that should be fine. Okay. Actually, yeah. No, that's fine. So that's going to be the same. And I think we can just call that. So navmesh query result is navmesh runtime find random point around circle. That would be from interop center. We'll actually need a vec3 here, so let's just call that point. And our max radius, that will be get random float for navmesh queries, and this will be point, and search box size we do have like that. And what is it complaining about? I don't know, actually. Let's see if we can just build this one thing. So that's the one we want, actually. Mesh ID. Oh, that's ID, right? That's probably better. Yeah, must return a value, but that's okay. We can just do that immediately. And if result is okay, then we will write from actually to interrupt. Sorry, to interrupt point. And that should return us and yes, and interrupt vec3. Okay. All right, and there we go. Now we have everything exposed to Zig that we will need for this, I hope. Okay, so let's think about a little bit about what we want to do. I think the first thing we'll actually want to do is draw the points that we kind of find good enough. And so I'm thinking I'll actually add a new component just for that. That will give us like an idea of is the system working or not. And then when we know it gives us what we want, then we can actually turn it into an actual spawning system, which shouldn't be all that much work. When we have those points, we can just go like, yep, that's fine. Okay, so new file, let's do something like spawn point visualizer component, and I'll just add that component to the player currently. I think this one will probably be pretty good, so we'll copy that and add it there. Probably doesn't need to be an avatar tracking, but whatever. Let's register it. And this is actually, I would consider like a test component, so let's just add it here in the first group. This is not something that we'll probably have in the game for very long. So test stuff, and we'll just add it there, like that. And so, what do we need? I'm trying to find one that is a game object component. Yeah. Because it doesn't need to be an avatar tracking component. And I think this guy will try to find a point to spawn on every second or so, and it will add that to a list. Like if it succeeds, let's just say, if it succeeds in finding a point to spawn around, then it will add that to a list, and then we'll just simply debug draw like a sphere or something around or wherever we have valid points. Then when we move around, we should start seeing more and more valid points, something like that. So yeah, let's get rid of that stuff. We don't need it, but we will perhaps want a message received, because there's another thing that I'm thinking we might want to do almost immediately, and that is the thing I mentioned about having like oh, this might not actually work now because it does work. Okay, yeah, that's the thing I mentioned about the nav mesh, about like excluding things that are off limits. So we'll want to add like a certain object or a number of certain objects if we have like nav mesh islands. Currently we only have one contiguous area that we can move around in. So we'll add one of those objects in the level, and that is supposed to tell the system like, okay, if you can reach this point, then you can actually spawn. Or hey, yeah, I think actually there's an even better way. We can just use the player position as the reference point, because the player position, like, the system will sort of need to know which player it is spawning enemies for, even if we have multiple players in the game. and they're running around in different parts of the level, the system will sort of need to know, okay, who am I spawning these enemies for, even though they can potentially kill any of the players and be killed by any of the players. So yeah, let's actually do that. Let's use the player position as the current position to the spawn point needs to have a valid path to. That should solve it. That means we don't have to add any additional objects there into the level. So yeah, let's do that. And since this spawn point visualizer will be added to the actual game object that is the player, then we can just use the current position as the reference point. And that will work fine. Private functions, we'll want to have some kind of dynamic list. And how do we do that in Zig? This folder doesn't seem to work. What is going on with that? Let's have a very quick look at my project file. Like that should be fine. That should be the Zigmaster lib. Oh, it's std actually now. That has probably changed at some point. Yeah, so now we can get the standard library here. And there's something called an array list. I happen to know, I haven't used this. At least I don't think I have. A contiguous global list of items in memory. That sounds like exactly what we need. So again, it's usually worth taking a look at the tests. So you init it, you pass an allocator to it, and then you can play around with it. So append, expect. All right, then. Yeah, those are of course testing stuff. Yeah, we can iterate. That's probably the value, and that's probably the index, I guess, or something along those lines. Then you can even use that. Okay, that looks like exactly what we want. So let's add valid spawn points, and it will be an array list of vec3s, and when we initialize ourselves, we make this valid spawn points is an array list of vec3 dot init, and we should be able to get an allocator from our context, I think. Let's make sure that is actually the case. Okay, closed everything when we modified the project. So yeah, it has an allocator. Right, so that should be fine. Let's see if it is. It is not. File not found. Okay. Seems to be in this. Yeah. We need to make it match the file path. Unused function parameters. Oh, I'm sure we have lots of those. Since I'll just take that away. We probably don't need it now that we don't need to communicate the position of the reference point. It should be fine. What do we have? Oh boy. Okay. Can I do something like this? Valid spawn points, or rather, come on, self.valid spawn points. Oh, undeclared identifiers. Oh, actually, yeah, my bad. What was it? STD? Array list, maybe? Something like that. Probably just need to actually specify it everywhere. Alright, yes, that's very true. And that is true as well. Actually, which one did we copy this from? It was probably like the weapon, was it? No. That was the aiming stuff. Because I happen to notice. Oh, come on. I happen to notice that. Right. Now it should build. Right. Okay, good. So now we have a list. We can add vector trees too, and in the update we will then want to do a little bit of debug drawing. And what did it look like, that array list thing we looked at here? So we have 4 list.items. Okay, list is the actual array list, so items. So we can do 4 self.valid spawn points.items, and we'll probably want to do, let's try to do just v, see if that works. Not exactly sure how those captures work, but let's try that. And we get the v, and we'll want to make it perhaps a little bigger. Actually, let's put here like a spawn point radius, and that's just, we're going to need that for various things. For example, for checking if an area which is that big is vacant, etc. So that's probably fine, and we can add. Let's use orange for these. No, actually, let's use green. I think green is probably quite visible. Okay, and then maybe just as a test, we can add. How do we add things to this? Append, apparently. Catch unreachable, yeah. Append vec3 init. So we'll add like, we'll add the origin. And then we'll move around a little bit, so like, I don't know, something like that. Oh no, actually no, not that. Let's not move up and down, let's just move something like that. We should have a line of 3 of those centered in the middle of the level. And now that we have this, we can just add add one of these guys to the player object. So this one. So spawn point visualizer and spawn point visualizer component, right? And maybe we'll actually only want to do this on the server, and since we're using only the debug draw, that's not how we do it. We need an if for it. if we're on the server. Since we're using only debug draw, we can currently do this on the server. Can't use like actual meshes and shaders and materials and whatnot. You can't use those on the server. That won't work, but debug draw works as long as you are running on the same process as the client and on the same thread as the client, which we currently are because of things like this. Right. That doesn't seem to. Oh, there we go. There they are. That's not really easy to see, but it's because they are inside the ground. Yeah, okay. That's probably fine. I think that'll be fine. Actually, we can just do this for simplicity's sake. We can just add this guy only on the server, and then we can get rid of these checks. Like so. We don't have to check that all the time. Okay. Right. Okay, so let's do const time between queries is let's have like 1 second between each query, and time since last query is f32 equals 0. And that's a remnant from the past. And also we can get rid of that, which means that we can get rid of that. Okay. So private function. Actually, before we do that, let's do the whole timed thing like we usually do. So we do plus equals tick time delta if self dot tick no time since last query is actually what we want here. If it's larger than or equal to time between queries, then we call self run query or find spawn point, and then we'll add that method and we'll call it fn find spawn point, and we'll immediately add the self here, and we'll just return void if it can't. That's fn. If it can't find a point, it just won't add it to the list of valid spawn points, and that'll be that. And of course we need to reset this back to 0. Okay, so we need a few more constants here. So let's call it outer find radius. Or no, let's call it max radius. And I don't know exactly what to put here. We'll probably just need to actually measure it a little bit. It's here in the level editor. For example, let's see if can we run the game here. We should be able to run the game directly from here. Yes, we can. Okay, so if this is the camera currently, and the guy is standing around here, I think like the inner radius should be about this length here. Let's just make a very crappy measuring stick for us. So let's make the inner radius like 15. This is now 15 world units. That's probably fine. It's just a ballpark figure, and we can tweak it. So 15, and then no, that's min radius, and then Minimax is a bit weird. Let's call that inner radius and outer radius. And I don't know, let's make it 25 or something. So that gives us like a circle, not a circle, but like a band around the character, which has valid spawn points. Okay. So, of course, center is just self.context.transform.getPosition. And what's the first thing we'll want to do? Well, I think we'll want to have like a loop of like some maximum set of iterations that we can try to do this thing. So let's set that up. Like if we don't find a spawn point for, shall we say, 10 iterations, then we'll just give up. So max query tries. That'll be 10, and we'll just put it here. And so we'll try for 10 times to get a point, and then we'll give up and try later again. Okay, so what do we start with? We'll need to get the random point around the circle. Okay, so let's see how we did that. That's in the navmesh runtime, which is here. We don't have it currently, so who has that actually? I've just used it like this apparently. Yeah, that's quite a bit. It's quite a long thing. We don't actually need that. Never mind. I'm rambling. Let's do const nav mesh query result, and we'll do the find. Oh, how I long for better. Oh, the completion. Find random point around circle, and so the navmesh ID is this guy, and then we have the center, I'm sure. Let's see, where was it? Navmesh runtime. So center, max radius is that's now the outer radius, right? And the result is a vec3, which we'll need to actually put in here. So we have, maybe we'll actually put it inside the loop. So let's call it point. Is undefined, I guess. No, we'll probably need to. We can just assign it to that. We probably need to initialize it before we use it. So that's point. That is address of point. And then search box size is I've typically used 10. So let's use that here as well. And let's perhaps try to see what happens if we use this. Do we get something sensible already here? So it was self dot. Actually, if navmesh query result is navmesh query result dot OK, then we can add this to self valid spawn points append, I think it was. Point. How do we ignore the errors? Array list. Catch unreachable. Catch unreachable is probably not completely fine to, or it is fine, but it's not that good because we're ignoring like out of memory situations essentially. Oh. But we are living on the edge. Okay. Okay. Let's try this. See what happens. I have no idea. Yeah, so we can actually let's kill all the enemies now. Boom. We can see that we have things starting to appear. They should kind of roughly follow the player. But they do appear kind of too close to the player currently. So yeah. Okay, well that's fine. That's fine. We can actually. It would be interesting to know how many iterations it did. So almost like std debug warn iterations, and let's just print like how many times did it have to actually run that before it got a valid point. And I think currently it probably doesn't need more than like one, but soon we'll actually start rejecting the points that it has selected for us. So like yeah, now we can see that it finds a point on the first iteration. Okay, cool. Let's actually speed up the whole thing a little bit and just for funsies, like make it 10 times faster. Okay, and now we can do. We have the inner radius. So let's do float squared distance to player. That would be center, and then we subtract the point and squared length. And if squared distance to player is smaller than radius times radius, which we'll need to do because we have the squared thingy, then we'll do. Can we do continue here? Is continue a thing in Zig? Maybe. We'll see. Actually, we'll probably want to do that like here, right? Inside this this check. Damn! I didn't save that before I built it. Okay, let's see what that gives us. Right, so now we can see that it has to do a few more iterations than just one. And if we actually move around here, we should see the cloud of spawn points moving around with us. The interesting thing is that we don't actually get, we don't seem to get those these like points on top of these guys. But I'm thinking that's probably just like a coincidence thingy. Okay, that's interesting. Let's speed it up some more. Yeah, we still don't actually have any. I don't need to kill all the enemies. I can just kill the enemies. The gameplay way. Come on. Die. Yeah, I still don't actually get any spawn points on top of those objects, even though they have sort of valid points on top of them. Yeah, we're getting quite bad performance now. It's actually probably the debug drawing. Like you can see, 70 FPS is not that bad, but the debug drawing is not really optimized for this kind of stuff. So that is what is causing it to tank, not the actual path generation. Okay, that's interesting. I think this actually gives us, like, this is a very promising start to what I'm trying to do, because it seems to work in the way that I expected it to. Like, it gives me positions that are some distance away, but not too far away. So good. Now then, we can. I think we should probably still do those checks and reject points that don't work out. So the first thing we will want to do is make sure we can get from this to this, right? And for that we will simply need to find a path between them. And maybe we can just copy the whole thing from here, right? Right, we have like... Let's actually comment this a little bit. So, get a point inside the circle defined by the player position and the outer radius, and then check if the point is too close to the player character. And then, yeah, too close. Right. And then, okay, check if there is a valid path to the player character to avoid spawning on top of obstacles, etc. Yeah, so yeah, I'm just gonna do like var path points, do it 32. No, it's actually like this. It's 32 vec3 undefined and var movement path length. Length u32 is 0, and I'll do const path result. That'll be basis nav mesh runtime find path. And again, we'll use the same nav mesh ID, obviously. And we'll do something like this. So search box size is probably 10, right? Where is it? There it is. Let's put it there, and then we can do the same thing here. And so we go from center to point. But we don't have movement path. We have path points, and we have movement path. Actually, why don't we just call it path length, like so. And if we don't have one, then we'll continue. No valid path between spawn point and player. So let's try that. Path result. Indeed. Okay, so now it actually can't find any paths. It's doing the full 10 iterations. Well, that probably just means that we made a boo-boo, and of course we did the boo-boo. So yeah, if it's not okay, then we continue. Okay is the only successful result, and there are a number of error results. Oop. And that looks good. You can see we still have like pretty good FPS, and then over time it starts going down. And that's expected because the debug draws are just like the list is just added to. Okay, excellent. And then then finally we still want to make sure that the place is vacant. And so to do that, we'll use the physics scene and the new function we added to there. Yeah, that should be fine. And I think if we use this as it is, it will probably return at least one, because it will overlap with the ground a little bit. So I think what we'll actually do is we'll move the spawn point up a little bit into the air, and that will, first of all, it will sort of rather than having objects spawn slightly inside the ground, it's perhaps better that they spawn slightly off the ground and then fall down onto it. And it will also fix the issue where it will overlap with the ground and give us kind of false negatives. So let's do that. Let's add another constant here, just like vertical offset, and it's a vector 3, and it's like 0, maybe 1.5, and then 0, something like that. And that's the once we have the point, here will actually, it's a variable, so we can add it to it. So point equals point plus the vertical offset. So we just move it upwards a little bit. And that is where we want to actually check for obstacles. Yes, and So context gives us the primary physics scene. Maybe we'll want to actually just save this. And we have it there already. Okay, physics scene. Right, so let's look at that and just put it here as well. So we have physics scene, and we need to do that. Don't need the messages, we don't actually use that at all. And then we'll make sure that we actually get a valid reference to it. And it just takes the center and the radius and returns overlapping objects. So overlapping object count, or actor count actually. Overlapping actor count. And that's self.physics scene get sphere overlapping. And we'll use point, and the radius is it is the what do we call it? Spawn point radius. There we go. And if overlapping count is not 0, then continue. This spawn point is blocked by another actor. So there we go. I think that should be all the checks we needed to do to actually get good spawn points currently. Yeah, and that looks like it's working, except of course it looks exactly the same as it did before, but that is to be expected. If we move far enough from those guys that they are actually in the way, then we will start to get in like things being blocked by them, but you have to have a certain amount of luck to actually have a spawn point generated where one of those guys happen to stand. But now at least we have a check for that in place, so that we don't accidentally do that. Okay. I think I'll end this video here, and the next video will actually take what we have now and turn it into an actual spawning system. And that should give us what we need then to like, we're approaching the like minimum feature set for an actual fully playable twin stick shooter. We still need player death, and we might want to add some like health to those enemies as well, so that they don't necessarily die from the first projectile hit, but rather after a while. But yeah, we're getting close. We're getting close. So I'll end this video here, and I'll see you all in the next video. Thanks and bye.